Hello everyone. In this video, I am going to talk about quadrilaterals. It includes concept of quadrilaterals, angle sum property of a quadrilateral, types of quadrilaterals, properties of parallelogram and midpoint theorem. So, what exactly is a quadrilateral? Here you can note that if all the points are collinear, we obtain a line segment. Like that, if 3 out of 4 points are collinear, we get a triangle. Similarly, if no 3 points out of 4 are collinear, we obtain a closed figure with 4 sides. Such a figure formed by joining 4 points in order is called a quadrilateral. And then comes properties of quadrilaterals. What are the properties of quadrilaterals? Now look at the figure. A quadrilateral has 4 sides, 4 angles and 4 vertices, right? Yes. In quadrilateral ABCD, AB, BC, CD and DA are the 4 sides. A, B, C and D are the 4 vertices. And angle A, angle B, angle C and angle D are the 4 angles formed at the vertices. Now join the opposite vertices, that is A to C and B to D. What we will get? We will get two diagonals, right? Yes, we will get a diagonals. That is AC and BD are the two diagonals of a quadrilateral ABCD. In this chapter, we will study more about different types of quadrilaterals, their properties and especially those of parallelograms. Okay. You may wonder, why should we study about quadrilaterals? Now look around you and you will find so many objects which are of the shape of quadrilateral, right? Which are they? For example, the floor, walls, ceiling, the blackboard, book, table, each face of the duster, each page of your book, the top of your study table are some of the examples for quadrilaterals. And then comes angle sum property of a quadrilateral. Let us now recall the angle sum property of a quadrilateral. The sum of the angles of quadrilateral is equal to 360 degree, right? This can be verified by drawing a diagonal and dividing the quadrilateral into two triangles. Let ABCD be a quadrilateral and AC be a diagonal. You know that angle DAC plus angle ACD plus angle D is equal to 180 degree. Put it as equation 1. Similarly, in triangle ABC, angle CAB plus angle ACB plus angle B is equal to 180 degree. Put it as equation 2. By adding equation 1 and 2, we get angle DAC plus angle ACD plus angle D plus angle CAB plus angle ACB plus angle B is equal to 180 degree plus 180 degree, that is equal to 360 degree. Also, angle DAC plus angle CAB is equal to angle A and angle ACD plus angle ACB is equal to angle C. So, angle A plus angle D plus angle B plus angle C is equal to 360 degree. That is, the sum of the angles of quadrilateral is equal to 360 degree. And then comes types of quadrilaterals. There are different types of quadrilaterals. Look at the figure and observe that if one pair of opposite sides of a quadrilateral ABCD in figure 1, namely AB and CD are parallel, you know that it is called a trapezium. If both pairs of opposite sides of a quadrilaterals given in figure 2 and figure 3 are parallel, recall that such quadrilaterals are called what? Parallelograms. So, quadrilateral PQRS of figure 2 is a parallelogram. In parallelogram MNRS of figure 3, note that one of its angles, namely angle M, is a right angle, right? What is this special parallelogram called? Try to recall. It is called a rectangle. The parallelogram DEFG of figure 4 has all sides equal, and we know that it is called what? It is called a rhombus. The parallelogram ABCD of figure 5 has angle A is equal to what? Angle A is equal to 90 degree and all sides are equal. It is called a square, right? In quadrilateral ABCD of figure 6, here AD is equal to CD and AB is equal to CB. That is, two pairs of adjacent sides are equal. It is not a parallelogram. It is called a kite. Here you can note that a square, a rectangle and a rhombus are all what? Are all parallelograms. A square is a rectangle and also a rhombus. A parallelogram is a trapezium. A kite is not a parallelogram. A rectangle or a rhombus is not a square. And the next one is properties of a parallelogram. In that, the first property is a diagonal of a parallelogram divides it into two congruent triangles. Let's prove this theorem. Okay, just look at the figure. What do you observe? Let ABCD be a parallelogram and AC be a diagonal. Observe that the diagonal AC divides parallelogram ABCD into two triangles, right? That is namely triangle ABC and triangle CDA. We need to prove that these triangles are congruent. In triangle ABC and triangle CDA, note that BC is parallel to AD and AC is a transversal. So, angle BCA is equal to angle DAC. These are pairs of alternate angles. Also, AB is parallel to DC and AC is a transversal. So, angle BAC is equal to angle DCA. These are also a pair of alternate angles and AC equal to CA. So, triangle ABC is congruent to triangle CDA, or diagonal AC divides parallelogram ABCD into two congruent triangles ABC and CDA. Like this, there are few more properties of parallelogram. That is, first one is, in a parallelogram, opposite sides are equal. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. In a parallelogram, opposite angles are equal. In a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. The diagonals of a parallelogram bisect each other. And the last one is, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Let us understand these properties by solving one example, okay? Here is the problem. Show that each angle of a rectangle is a right angle. Let us recall what a rectangle is. A rectangle is a parallelogram in which one angle is a right angle. Now look at the figure. Let ABCD be a rectangle in which A equal to 90 degree, right? We have to show that angle B equal to angle C equal to angle D, which is equal to 90 degree. We have AD is parallel to BC and AB is a transversal. So, angle A plus angle B is equal to 180 degree. But angle A equal to 90 degree, right? So, angle B equal to 180 degree minus angle A, which is equal to 180 degree minus 90 degree. That is equal to 90 degree. Now, angle C is equal to angle A and angle D is equal to angle B. That is opposite angles of the parallelogram. So, angle C is equal to 90 degree and angle D is equal to 90 degree. Therefore, each angles of the rectangle is a right angle. And the last one is midpoint theorem. You have studied many properties of triangle as well as a quadrilateral, right? Now let us study another result which is related to the midpoint of sides of a triangle. Just perform the following activity. Now just draw a triangle and mark the midpoints E and F of two sides of a triangle. Join the points E and F. Measure EF and BC. Also measure angle AEF and angle ABC. What do you observe? You will find that EF is equal to half of BC and angle AEF equal to angle ABC. So, EF is parallel to BC. To understand this concept, let's go for one more theorem, okay? The line segment joining the midpoint of two sides of a triangle is parallel to the third side. We can prove this theorem using the following clues. Observe the figure in which E and F are midpoints of AB and AC respectively, right? And CD is parallel to BA. Triangle AEF is congruent to triangle CDF, that is by ASA rule. So, EF is equal to DF and BE equal to AE, which is equal to DC. Therefore, BCDE is a parallelogram. This gives EF is parallel to BC. In this case, also note that EF is equal to half of ED, which is equal to half of BC.